Okay guys, so for today we are going to be looking at taking our residual plot, kind of what we second half of the notes yesterday, and we're just going to practice with that a little bit more. So we're going to take our residual or our information, we're going to scatter plot it, we're going to find the line of best fit, we're going to find the plot the residuals, and then we're going to make some assumptions about what we can do with this. So what I want you guys to do first is write down the data information. So let me zoom in for you. So I'm not even telling you what information this shows. I'm just giving you our data. If our x is 1, our y is 37.5, 2, 35.5, and so on. So what I want you to first do is to write down the chart in your notes. I know. Okay, so for this problem, the first thing they want us to do before we can do anything in the chart is to determine the linear regression equation. So that's the first step that they want us to do, determine the linear regression equation. Now, for the sake of time, because it would take the entire class period if we wanted to calculate all that by hand, I'm going to give you the A and the B and the R, and then we're going to use those to do everything else. So on top of the chart, or right next to it, I'm telling you right now that A is equal to negative 2.51, B is equal to 40.18. So in your groups right now, right here where it says linear regression equation, I want you to use those values to give me the linear regression equation. Okay? So based on that A and B value, can somebody tell me what the linear regression equation would be? Jonathan.
Negative 2.51.
Wait, I'm stopping you already. You forgot something. Anthony.
Y equals.
Y equals. Okay, Jonathan, keep going.
Negative 2. Y equals negative 2.51 x plus 40.1.
Plus 40.18. Perfect. Thumbs up if you got that as your linear regression equation. Fabulous. Like I said, on the homework, I will give you the A and B values because it's going to take you forever to do some of these. Now, do a comma next to it. I'm also going to tell you what R is. R is equal to negative 0.9993. Okay, so there's your R. Okay, so the next step then, the next step that they want us to do is to construct a scatter plot. Before we can do that, we need to actually find, we can construct an actual scatter plot. So let's do that next. So what I want you guys to do is right underneath, construct your scatter plot first, and then we'll graph the first couple pieces together. Okay. Okay, so to construct our scatter plot, the scatter plot, remember, you plot the actual values, not the predicted. So our first coordinate is going to be 137.5. So I'm going to go right one space, and I know that mine goes up to 40 on mine. So this would be 38, and we would be somewhere right there. So construct your scatter plot. That would be your first point. My next point would be 235.5. So I'm going to go right 2, and then if this is, let me count, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and I'm going to 35. So 32, 34, 35 is going to be right there. So there's my next scatter plot value. I want you guys to finish constructing the scatter plot for me. So I did 1 and 2. You need to go 3 through 8. You can work with your people in your groups. Okay, guys, so here's what mine looks like. It's probably not exact, but it's pretty close. Does your guys look kind of like that? Okay, does this look linear? It looks pretty linear. Let's try and draw a line of best fit, okay? So it's not going to be perfect, but let's try and draw a line that goes through all of those. I suggest that you use, like, the edge of your binder or another piece of paper or something. So I'm going to use my paper, and I'm going to try and draw a line that goes through as many of the points as possible. So just try and draw a line of best fit for me just so we can see it. So it should look something like that. Try and hit as many points as possible. It shouldn't be that hard because your scatter plot should look pretty linear. Okay? Okay, so here's the next part. The last part wants us to construct the residual plot, but we can't because the residual plot means we have to subtract the predicted value from the actual value. So that's what we have to do now is fill out our chart, okay? So I'm going to have you guys fill out the chart. You might need a calculator. I will do the first one with you. So our first x is 1, so we're going to plug that in for x here. So that's going to be negative 2.51 times 1 plus 40.18. So that's going to give us a predicted value of 37.67. Okay? I want you guys to fill out the rest of the predicted values first. Let's check predicted values with each other first before we actually do the residual values. All right, what did you guys, so we know that the first one would be 37.67. What did you get for x equals 2? 35.16. Okay, what about x equals 3? 32.65. X equals 4? 30.14. X equals 5? 27.63. 6? 25.127. 22.61. And 8. 20.10. Perfect. Okay, that's exactly what I got too. Okay, so the next step then would be to calculate the residual value. So remember, residual values, we subtract the predicted, the actual and the predicted. So actual minus predicted. So our first residual value would be 37.5 minus 35.67. So that would give us a negative 0.17. So finish the rest of the residual values for me, please. Okay, so what did you get for your second residual value? 0.34, positive, right? What about the next one? Negative 0.15. Okay, what about the next one? Negative 0.14. Next? Negative 0.13. Next one? 0.38, negative 0.11, and then negative 0.1 or 0.10. Okay, perfect. So when we subtracted, you should have got these residual values. So our very last step is to plot those residual values, okay? So I'm going to see if I can get it all up here. So we're going to just plot the residual values. Remember, your x-axis is the x values, your y-axis is the residuals. Because our x's only go from 1 to 8, that's all you have to do. So 1, 2, 3, 4, 5, 6, 7, 8. This one actually goes to 10, but you only have to go to 8. And all of our residual values are in between negative 1 and positive 1. So you just have to make a big 1 and then maybe a 2 if you want to go a little higher on your graph, or then a negative 1 and a negative 2 there on your y-axis. So write that out really quick and then we're going to plot. Okay, guys, so let's plot this. Our first one is 1 and negative 1.7. So remember, this is a negative 1, so halfway would be negative 5. So 0.17 is not that that far down from the x-axis. So it's going to be somewhere right there. Our next value is 2 and positive 0.34. 0.34 is still in between 1/2 and 1. But it's going to be a little bit higher, so somewhere about right there. I'll do one more with you, and then I'm going to have you guys finish it. So the next one would be 3 and 0.15. Negative 0.15 is smaller than negative 1.17, so it's going to be just a little closer to the x-axis than your first one was. And then I want you guys to finish it. So finish plotting your residuals. All right, so your residual plot should have looked something like this. Is that kind of what you guys got? Okay, so let's make some assumptions then based on what we found. So I'm going to zoom out just a little bit. Oops, that's not out, that's in. Okay, so the first thing we want to do is, in our homework, we looked at the scatter plot and the correlation coefficient first. So let's just look at that. So here's our scatter plot, and here's our correlation coefficient. Does a linear model seem appropriate based on those two things? Yes, so I want you to write that. Based on the shape of the scatter plot and correlation coefficient, a linear model, and then we decided seems appropriate. So let's say appears appropriate. For the data. So I always want you to look at just the actual information that was given first. So our scatter plot and our correlation coefficient. So based on that, the linear model does seem appropriate. Okay, so let's look at the residual plot then, guys. Does it appear to be flat or have no pattern at all? Pretty flat, right? So does the residual plot indicate that a linear model is appropriate also? So I want you to write that as a separate sentence, okay? So based on the residual plot, a linear model appears to be appropriate for the data. Okay, so you need to look at the actual values that are given and the residual plot separately, because sometimes they might be telling you two different things. So for the data. Okay? So that's how we can use all of the information that was given to us and residual plots to make assumptions about our data.